Okay, so we have this question here. It says, given the function f of x equals x plus 1 over x minus 1, that's f of x, g of x, x minus 1 over x plus 1, and h of x equals 3x. Determine the following and simplify. So part A, they're saying determine and simplify f of gx. So colleagues, when you see this here, this is a compound function. It's a function within a function. Okay, that's a compound function, a function within a function. So basically, what this is saying here in simple terms is the function g, you're going to put it in the f function. So where you see an x in the f function, you substitute it with the g function. Let me repeat myself. The compound function here is f of g. So it means the g function, you're going to put it in the f function. So where you see an x in the f function, you substitute it with g. Okay. So let me write first our x function here. F of x equals x plus 1 over x minus 1. So where we see these x's here, we're going to substitute them with the g function. Okay, colleagues? So now our function is going to become, so this x, we substitute it with g. Okay, this g function is coming where there's x. So we're going to put x minus 1 over x plus 1 plus 1 over x minus 1 over x plus 1 minus 1. Any questions, colleagues, before we start to solve further? Okay, can I hear your answers? Those who solved this one, can I hear your answers? Or you want to wait for me to give you the answer? Okay, actually, let me first yeah, let me finish solving so that yeah. So okay. So colleagues, well, let's start on the numerator. We solve the numerator. We also solve the denominator, right? So this is like the numerator is going to be, let me put it here. So x minus 1 over x plus 1 plus, so this one here, you can think of it as 1 over 1. Okay, so remember with fractions, multiply the denominators, x plus 1 times 1 you get x plus 1. Okay, because you're basically saying 1 times x, that is x. 1 times 1, that is 1. Okay, then you multiply 1 times x minus 1. Okay, 1 times x minus 1. So 1 times x, that is x. 1 times negative 1, that is negative 1. Plus, then you multiply x plus 1 times 1. Okay, and you're going to get x plus 1 here. Any questions before I move further? Okay, so we simplify. Remember, we're just operating on the numerator first. Okay, yes, so on the here we have x minus 1 plus x plus 1. Okay, when the sign is positive in front of these brackets here, you can leave the, because it's just the same as saying 1 times 1, that is x, 1 times 1, that is positive 1. So you can just leave it like this. But when the sign is negative, what's in the brackets changes. So you just add like terms together. So here, x plus x, that is 2x. Then negative 1 plus 1, that is 0. Okay, so you have 2x over x plus 1. That is for the numerator here. 2x over x plus 1. Any questions before we solve the denominator? It's the same as solving for the denominator. Can I show you first for the denominator? Yeah, it's just the same method. So we come to our denominator here, x minus 1 over x plus 1 minus 1. So we just put over 1 basically, since we're solving as fractions. So with fractions, remember, first things first, multiply the denominators. So you're going to say 1 times x plus 1. Basically, you're going to say 1 times x, that is x, plus 1 times 1, that is 1. Okay. The next we go, so you start on the bottom right. Okay. Going to say 1 times x minus 1. Okay. 1 times x minus 1, like this. So 1 times x, that is x, 1 times negative 1, that is negative 1. Minus. Okay. Then you go to the bottom left. Then you're going to say this x plus 1 times this one here. And then this one on top here. 1 times x, that is x, plus 1 times 1, that is 1. Then here on the numerator, we need to simplify. So here it becomes, let's say, it become x minus 1. Then here, since there's a negative before this bracket, say, so it's a negative times x, get negative x. Negative times positive 1, you get negative 1 over x plus 1. Then you just combine like terms. X minus x, that is 0. Negative 1 minus 1, that is negative 2. So you get negative 2 over x plus 1. Madam, is that okay? Okay. Any questions, colleagues? So we have 2x over x plus 1 over negative 2 over x plus 1. So it's like we're dividing these fractions now again, okay? So colleagues, remember the shortcut. The denominator for this top fraction and the denominator for the bottom fraction are the same. You can cancel them out so that it just becomes negative 2x, 2x divided by negative 2. 2x divided by negative 2, you get negative x as your answer. Okay. Now, colleagues, do I need to show how these x plus 1s disappeared, or we're okay with that? Compound function, sir. This one is a compound function. And have you seen the function that they've given you? They are fractions. So, very involving this one. And you need to be patient because, how can I say? You can make mistakes, especially with these negative and these negative signs and whatever. Mm, yes. Because this one is very involving, as you can see. So yeah, you do it in a step-by-step basis, yeah, so that you are not prone to mistakes. And just remember, colleagues, the way we deal with fractions is the same way we are solving here. It's just because that these fractions have got x's and x's plus 1. But the way I solved the fractions is just the normal way we do with fractions for grade 5, grade 3. Okay. Okay, can we go to part B? Mhm. Where are you talking about? Which x outside the bracket? Oh, this x here. Oh, this x. Yeah, you don't consider it. It's just telling you f of g of x, basically. So, yes. Mm. But you're going to see here, like in part 2, here, the difference with part 2, part B and A. Have you seen here? There's a 2 at the end. So, what it's basically telling you is that after you got your compound. Oh, madam, could you kindly mute your mic? Could you kindly mute your mic? Yes. So when there's an x at the end here, once you've got your compound function, you end there. But when you have a number at the end here, what it means is after you get your compound function, then you substitute that value for x so that you simplify further. Okay? So let me just illustrate that. So our at the end, at the end, you put yes. 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 So for example, if x was 4 here, you would have now said this answer would have become -4 as our answer. Yes. All right. So we've got now g of h. So it means our h function, we're going to put it into our g function. So basically, in our g function, where there is an x, we substitute it with the h function. Yeah. So colleagues, are the drawings, you're able to see the writings, they're not too light, huh? You can, yes, this one has, it's a definite that I'm recording, sir. Yes. I'm asking, are the writings too light or you can easily see them? What I'm writing on the board, my workings, are they very visible? That's my main concern here. Okay, so this is our g of x, x minus 1, x plus 1. So where it is x, we're going to substitute it with our h function. Okay, so this is going to become, so here this x, we substitute it with 3x. Because remember, h of x is 3x, so where there's x, substitute with 3x. So at least this one is more consumer friendly than the other one. In our denominator again, where there's x, substitute it with 3x. So our g of f function is 3x minus 1 over 3x plus 1. This is g of h. Now, since we've got this 2 here, okay, so it means where there is x, you substitute it with 2. Okay. If there was no 2 here and there was just an x, we would have ended our question here. Okay. If this was an x here, we would have ended here. But since there is a 2, so it means now we need to substitute. So there is a lot of substitution going on. So 3 times 2, that is 6. 6 minus 1, that is 5. Over 3 times 2, that is 6. 6 plus 1, that is 7. So 5 over 7. That is your answer. Sorry about that. These adverts on the phones. Yes. Any questions, colleagues, before we go to part C, where we have to find the inverse of f of x plus 1? Okay, next, inverse functions. So the next question is find the inverse of f of x equals x plus 1 over x minus 1. So for inverse functions, we have to find the inverse. Okay. So step 1, okay, put the function in standard form. So what we mean put in standard form, this f of x becomes y. So it says y equals x plus 1 equals x minus 1. Step 2, make x subject of the formula. Okay, so basically what we're going to do here first, we need to cross multiply. All right, so we're going to say x minus 1 times y. So it's going to be y, we have x minus 1 here equals this x plus 1, we cross multiply there, becomes x plus 1. So first we've cross multiplied, okay, then on our left hand side we expand y times x, that gives us xy, y times negative 1, that is negative y, equals x plus 1. Okay, So we want to make x the subject of the formula. So this negative y, we take it over the equal sign, and this x here, we're going to bring it to the left hand side, and the y will go to the right hand side. So we have x y minus x equals 1 plus y. Okay, then at this point we've got a common factor, which is x here, so we can factorize. So we remove the common factor, put it outside of the brackets. So you're going to say xy divided by x, that is y, minus x divided by x, that is 1. Okay, so to get the value of x, divide both sides by y minus 1. So x equals 1 plus y over 1 minus y. And then, oh, before I go further, any questions? Any questions, queries? Okay, then the final step, you replace this x with f to the power negative 1x and negative 1. This represents inverse function. And these y's here on the right hand side, you replace them with x. So it becomes 1 plus x over then this y here also x minus 1 here. Okay, colleagues? So what has happened here in this final stage? This x here has become the inverse function symbol. Then these y's here, this one here at the bottom, this one at the top, they've changed back to x. All right, so that is the inverse. Yeah, surprising. The same is basically the same expression here. It's basically the same expression. So those are the steps for inverse functions. Okay. Step one, you put in standard form, where you make substitute f of x with y. Step two, you make x the subject of the formula. Then step three, okay, you substitute the y's with x, and this x is substituted with the inverse expression, this f to the power negative 1 x. Yes. Questions, queries? That's how it is done.